Well, there's many contributing factors. So number one, it's the farming practices.
Mm,
Number two, it's the amount of lightning storms in those particular areas because the air we breathe is 78% nitrogen.
got it.
And through lightning fixation, it breaks that N2 bond, that very strong triple bond, and then basically called nitrogen fixation. So in areas where there's more thunderstorms, there's more nitrogen in the soil in the form of nitrate. And then the other thing is we compared conventionally grown vegetables to organically grown vegetables.
Right. Hi, everyone. It's Dr. Goel here from Peak Human Labs, and today I have a great guest for you, Dr. Nathan Bryan. Dr. Bryan is an expert in nitric oxide physiology, and he's also come up with some really cool formulations to improve nitric oxide getting into your body. Today, you're going to learn all about the health benefits of nitric oxide and why you need to make it part of your supplement routine. All right, we'll see you on the other side. Hi, Dr. Bryan. Thank you so much for joining me. I really appreciate your time.
Well, thanks for having me. It's great to be with you. Great to see you again.
No problem. So, you're an expert in nitric oxide, and I want our viewers to kind of understand your background. I mean, how did that actually come to be? Like, why did you get involved in that aspect of biology?
Yes. Just like every career, it's a journey, right? And we never know where our career is going to take us.
Right.
I had a degree in biochemistry from the University of Texas, a Bachelor of Science degree. I then went to LSU School of Medicine. I got a PhD in molecular and cellular physiology.
Okay.
And it was there where I was introduced to this whole new science of nitric oxide.
Right.
This was the late 90s, and the Nobel Prize had just been awarded for the discovery of nitric oxide.
Yeah.
And Lou Ignarro, one of the gentlemen who shared the Nobel Prize, came to LSU and gave a lecture before the student body. And I had a conversation with him and had dinner with him that night, and it was a really fascinating science. And he just said that there's so much we don't know about this molecule. We know it's a gas that's naturally produced, regulates blood flow, circulation, oxygen delivery,
Mm-hmm.
but we don't know how to really detect it in humans, and we certainly don't know how to restore or develop therapeutics for a gas that's gone in less than a second. And so that was really my entry into the science of nitric oxide, and really finished my PhD on really in analytical chemistry, trying to figure out how can we detect physiological levels of nitric oxide
Mm-hmm.
in vascular tissue, in heart muscle, things like that.
Mm-hmm.
And then once we developed these methods where we could detect physiological amounts of nitric oxide, then we started looking at different disease models and trying to create a fingerprint of NO biology in many different disease states.
Mm-hmm.
And so that's really what started my career more than 25 years ago.
Wow. So just take us through that. So 1998 was when the Nobel Prize was awarded for what was it? Not obviously not the discovery, but the understanding the importance.
Well, it was the discovery of nitric oxide as a signaling molecule in the cardiovascular system. That was what the headlines for the Nobel Prize was.
Mm-hmm. Okay. And so let's start talking about that then. So nitric oxide, we generally think about it as, when people take Viagra and Cialis and all this, people understand that has some impact on blood flow. But nitric oxide is much more than just a vasodilator. Is that correct? Or it sounds.
No, it's true. I think there's a misconception about the drugs like Viagra, the PD-5 inhibitors, because they do not affect nitric oxide production.
Oh, okay. Yeah.
They work downstream of nitric oxide.
Right.
So those drugs are actually dependent upon the body's ability to produce nitric oxide.
Yeah.
And today we know, these drugs have been on the market for 25 or more years, and they only work in 50% of the men in which they're prescribed.
Mm-hmm.
And the reason there's 50% non-responders is because they're not making enough nitric oxide to activate the second messenger cyclic GMP, so PD-5 inhibitors can't work. So it told us many years ago that erectile dysfunction is a symptom of nitric oxide deficiency. But going back to the original question, yeah, it was discovered to be a vasodilator. And the Nobel Prize was awarded due to the elucidation of the mechanism of drugs like nitroglycerin, organic nitrate, and really medications that have been used for about 150 years
Mm-hmm.
for the treatment of acute angina,
Mm-hmm.
because they worked. No one knew how they worked. And it was Fred Mira who discovered that these drugs are metabolized into nitric oxide, activate guanylyl cyclase, lead to cyclic GMP, an increase in calcium mobilization, and smooth muscle relaxation. And then it was Bob Furchgott in 1980 who discovered that our endothelial cells makes a substance that causes blood vessels to relax. And in that 1980 Nature paper, he called this EDRF, or endothelium-derived relaxing factor.
Mm-hmm.
And then 7 years later, Lou Ignarro discovered that EDRF is nitric oxide.
So
So that was in
EDRF.
the 80s.
What was it? What was the
Yeah.
mnemonic? EDRF.
EDRF, endothelium-derived relaxing factor.
Oh, okay, got it. Mm-hmm.
So Bob Furchgott described what this molecule did,
Mm-hmm.
but no one knew what it was. And then for the next 7 years, people thought, the scientific community believed it to be nitric oxide. But how do you design an experiment to demonstrate that it's nitric oxide gas that's responsible for the vasorelaxation effects, acetylcholine or endothelial alveoli?
Right.
But so the fast forward 25 years, 35 years, and we now know that it's the molecule that tells our own stem cells to mobilize and differentiate. It prevents telomeres from shortening. So it activates the telomerase enzyme, prevents telomere shortening,
Mm-hmm.
and it activates mitochondrial activity and mitochondrial biogenesis.
Right.
So it's really everything we know about health and longevity
Right.
is dependent upon the cell's ability to produce nitric oxide.
Yeah. So let's take our viewers through a little bit of the how is nitric oxide formed. I understand there's two pathways. If you could just take our viewers through that. Yeah. Let's do that because I think that
Sure.
would be helpful.
No, I think it's very important to understand those pathways because you really can't develop rational therapeutics or product technology until you understand, number one, how the human body makes nitric oxide,
Yeah.
and then number two, what goes wrong in those patients that can't make it. So this first pathway to be discovered
Mm-hmm.
was an enzyme in the endothelium. That's the single layer of single layer of cells that line all blood vessels.
Mm-hmm.
And there's an enzyme called nitric oxide synthase.
Yep.
And this enzyme converts L-arginine
Yes.
into nitric oxide. And this is a very complex 5-electron multi-step oxidation reactor. And it's energetically and kinetically unfavorable.
Got it.
So when you understand the biochemistry and the enzymology of that, we thought maybe 25 years ago that there has to be another way to make nitric oxide. Because if this molecule is so important,
Mm-hmm.
nature wouldn't develop a single pathway that's so damn complicated that can be so disrupted at many different steps. And so that's the pathway that really becomes compromised with age. The older we get, we call this endothelial dysfunction, the less nitric oxide we make through that enzyme.
Okay, so let's
And it's never a deficiency of arginine. So giving more L-arginine to these patients with endothelial dysfunction
mm-hmm.
isn't the fix. And in fact, it can cause more harm than good. So that's the first step that was the pathway to be discovered. And then about 25, well, maybe even 35 years ago, it was starting to be recognized that nitric oxide can be produced in the lumen of the stomach, and that you could enhance this nitric oxide production by eating green leafy vegetables. You could eradicate it by using antacids,
Yeah.
and you could eradicate it by using antiseptic mouthwash. So now, today, we understand that it's the nitrate that's found in green leafy vegetables.
Mm-hmm.
It's the oral bacteria that metabolize nitrate into nitrite, perform this 2-electron reduction.
Mm-hmm.
And then when we swallow our saliva and it hits the acid environment of the stomach, then it produces nitric oxide gas. So number one, you had to get enough nitrate from your diet. Number two, you must have the right oral bacteria.
Mm-hmm.
And number three, you must be able to make stomach acid production.
Right. Mm-hmm.
And now, once you understand that, you really become in a keen understanding of why Americans are sick, or why really most Westernized nations are sick.
Mm-hmm.
Number one, we're nutrient deficient.
Yep.
Standard American diet, we're not getting enough nitrate. 2 out of 3 Americans wake up every morning and use mouthwash, killing the oral microbiome. And those are 100 million prescriptions written for antacids every year. And now you don't even have to have a prescription. You can go to the drugstore and you can get, Prevacid, Prilosec, Nexium, these drugs over the counter.
Mm-hmm. Mm-hmm.
And so it completely shuts down nitric oxide production.
Yeah, no, okay. So I want to unpack a couple of these things. So the first one we talked about is the arginine pathway, and generally a lot of these sports kind of like drinks were all based on people taking arginine. And I even had heard, even when I was early days, when they used to talk about, creams and things like that would help like stimulate blood flow, I think, they would put arginine in them. So I guess this is all built on this idea of taking arginine. But you're saying as we get older, that pathway becomes weaker? I mean, that becomes not as efficient, that enzyme?
Yeah, because arginine is a semi-essential amino acid. And what that means is that we get part of it from the breakdown of proteins that we eat in our diet.
Yeah.
It doesn't matter if it's plant-based protein or animal-based protein.
Right.
And then we make it through the urea cycle, the partial urea cycle,
Mm-hmm.
which is found in every cell type in the body.
Mm-hmm.
So there's never a deficiency of arginine in the human body that leads to nitric oxide deficiency.
Got it.
The rate limiting step is the oxidation of tetrahydrobiopterin, or BH4.
Mm-hmm.
And then when that happens, this homodimer, the enzyme is two twins that come together that allow for this flow of electrons to lead to the oxidation of arginine. But when BH4 is oxidized, it uncouples, and now this enzyme produces superoxide instead of nitric oxide.
Okay.
There's a disruption in the flow of electrons, and we reduce molecular oxygen to superoxide.
Mm-hmm.
And if you give arginine, you actually exacerbate that reaction and lead to more oxidative stress, more superoxide production. So you can make things worse.
Oh, okay. And is there any other amino acids that are involved in that pathway apart from arginine?
No, I mean, citrulline is a byproduct of nitric oxide
Mm-hmm.
production. And then again, through that partial urea cycle, through an enzyme called arginosuccinate synthase and arginosuccinate lyase,
Mm-hmm.
citrulline is converted back to arginine. So it's a metabolite reshuttling, repurposing those metabolites to reproduce nitric oxide.
Because we see people put out citrulline is also in a lot of these workout type of formulations as well.
Yeah, it's a clear indication that they don't know what they're doing and they don't understand the biochemistry.
Mm-hmm. Mm-hmm. Right. Okay, and then now we're talking about then the second pathway is you're saying through the diet, and is it nitrates or nitrates? What is it that's actually taken in through? Is it plants only, or where do people get?
Well, it's both. I mean, primarily the most predominant molecule is nitrate.
Mm-hmm.
Because when plants are grown in soil, there's nitrogen in the soil. The plants assimilate this into nitrate. So when we eat those plants or vegetables, then we're um, exposed to the nitrate. And also, if you have bacterial contamination on the leaf or on the vegetables, then these bacteria can reduce the nitrate to nitrite.
To nitrite.
So we really get a source of both,
Mm.
but predominantly it's nitrate.
Okay.
And then we rely on the body to convert that into nitrite, and then the body can convert nitrite into nitric oxide. But humans do not have a functional nitrate reductase enzyme.
Okay.
So we're 100% dependent upon the bacteria.
Right. Okay.
And when we overuse antibiotics, when we use fluoride in our toothpaste, when we use antiseptic mouthwash, we completely eradicate bacteria,
That
and it leads to nitric oxide deficiency.
got it.
We and others published about 10 or 12 years ago that if you use mouthwash, we see an increase in blood pressure,
Right.
and you lose the protective benefits of exercise.
Mm-hmm. Right. I'd love to explain that study in a bit. But is nitrates only available in plant, or are they found also in meat products?
They're found in meat products because, the animals eat the grass or the vegetables, and it's stored in their muscles or their blood.
Right.
And so when we eat the animal proteins, we're getting a source of the nitrate. Now, it's much lower, maybe in 2 orders of magnitude lower than what you get from eating, the plants directly.
Mm-hmm. I had heard that there was a lot of variation in soils that some soils that could be grown in different parts of the country have much different amounts of nitrates. Is that correct?
Yeah, that was a really interesting study we published in 2015. And the rationale or the motivation behind that study was how much broccoli, celery, spinach, or vegetables would one need to consume to get enough nitrate to manage their blood pressure.
Mm-hmm.
And if we could determine that, then we could change the dietary guidelines and say, look, for those with an elevation in blood pressure,
Mm-hmm.
if you eat this much broccoli, celery, spinach, or lettuce,
Mm-hmm.
then that'll manage your blood pressure. So we went to New York, Raleigh, Chicago, Dallas, and Los Angeles, kind of 5 corners of the U.S.
Mm-hmm.
And we measured the same vegetable
Mm-hmm.
from the same retail grocery,
Mm-hmm.
brought it back to the lab, analyzed it, and we found that there was as much as a 5 to 10-fold difference in the amount of nitrate found in celery in Dallas versus celery in New York.
So yeah, that's huge. So why is that?
Well, there's many contributing factors. So number one, it's the farming practices.
Mm-hmm.
Number two, it's the amount of lightning storms in those particular areas, because the air we breathe is 78% nitrogen.
Got it.
And through lightning fixation, it breaks that N2 bond, that very strong triple bond, and then it's basically called nitrogen fixation. So in areas where there's more thunderstorms, there's more nitrogen in the soil in the form of nitrate. And then the other thing is we compared conventionally grown vegetables to organically grown vegetables
Right.
in those same regions, and we still saw the same variation. But the eye opening kind of observation was that organic has about 5 to 10 times less nitrate than conventionally grown vegetables.
Because of,
And to understand
yeah,
that,
fertilizers.
to get an organic label in the
Yeah,
U.S. at least, you can't add herbicides or pesticides, but you also can't add nitrogen-based fertilizer.
that's right.
So without nitrogen in the fertilizer, nitrogen in the soil, the plants become nitrate deficient.
Yeah, so that then it's an argument for not taking organic, but not necessarily healthier in that aspect.
I tell people go to your local farmers market
Right.
and understand where your food is coming from, not just your vegetables, but the meat you're buying.
Mhm,
Uh, what I do, it's kind of a combination of both.
mhm,
I add nitrogen to the soil. I do soil samples so I know what's missing and know how much to put back in, but I don't use the herbicides or pesticides. So my vegetables that I grow on my ranch are not considered organic,
mhm,
but they're nutrient dense, pesticide, herbicide free
mhm.
food.
Wow, that's very interesting. That's I just let's just follow up on that. So, what if this type of testing is not something that's in the hands of most people? I assume this is like to know how much nitrogen and how do you do that?
Well, in the U.S., the United States Department of Agriculture, through their local offices, if you take a soil sample
Yeah.
to the local outreach office, they'll do soil analysis for you.
Okay.
And then they'll tell you, okay, how much nitrogen's in your soil, how much sulfur, um, potassium, phosphorus do you need to add to that soil
Hmm.
to make it to where it's going to be dense enough to where you're going to get good crop yield and be able to have a nutrient dense food.
Right. Okay. And what is the amount that would be just? I mean, just as just number, just so I can understand that. What or is there any? Is there no upper limit? Like, what is the safe amount that would be in a soil, or that would be?
Well, I think it depends upon the soil type.
Hmm.
Where I live in Central Texas, it's what we call a sandy loam. And so typically I'll have to add lime to the soil to alkalinize it.
Hmm.
And then I'll usually use 28% nitrogen. It's called a 28-14-7-3. And that's the nitrogen, the phosphorus, the potash, and then the sulfur.
Hmm.
But that may vary depending upon, what crops I'm growing.
Right.
If I've rotated my cattle through there where they've actually fertilized and pooped and stepped into the poop and put it into soil.
Mm-hmm. Hmm.
So it just depends upon the conditions and the amount of rain, the sunlight,
Hmm.
and the weather conditions.
Right. Okay. That makes a lot of sense. Okay, so you talk about the use of antacid. So you're obviously talking about proton pump inhibitors as well. Anything that's going to reduce acid production, which will then prevent the I guess the bacteria from surviving, or is it from
No, it's
breakdown?
basically just the acid disproportionation of nitrite that's in our saliva
Hmm.
that when it reaches the acid environment of the stomach produces nitric oxide gas.
Oh, okay,
So anything that suppresses stomach acid is going to affect that reaction.
okay,
But proton pump inhibitors specifically also inhibit an enzyme in the lining of the stomach called DDAH,
okay.
and that leads to an accumulation of asymmetric dimethyl L-arginine,
Hmm.
or ADMA.
Hmm.
And now that's going to inhibit the vascular production of nitric oxide. So the proton pump inhibitors completely inhibit nitric oxide from both pathways. And now, if you look at the data, the outcome data,
Hmm.
people who have been on PPIs for 3 to 5 years have about 40% higher incidence of heart attack, stroke, and Alzheimer's.
Wow. Okay.
So the clinical outcomes are very clear and irrefutable.
Huh.
And now, mechanistically, we can explain what's leading to heart attack, stroke, and Alzheimer's. It's complete inhibition of nitric oxide.
Hmm. Is there any, well, in your mind, is there any safe amount of these PPIs that people can be taking? Do we know in studies like what I mean to affect
No,
nitric
I don't
oxide
think
production?
so. And well, not that I'm aware of. I don't think there's ever been any dose dependent. studies on these PPIs.
Mm-hmm.
There's certainly been no long-term safety studies
Mm-hmm.
because in the U.S., the FDA approved these drugs only for acute use,
Mm-hmm.
14 days at most.
Mm-hmm.
That's how the clinical trials were designed.
Right.
But yet now you have people taking these every single day
Mm-hmm.
for 5, 10, 15, 20
Right.
years. And the consequences are deadly.
Right.
I mean, all you have to do is read the package insert on these.
Yeah.
If patients or consumers would read the package insert
Mm-hmm.
and realize that it's causing kidney disease, it's causing osteoporosis,
Mm-hmm.
uh, kidney damage. Because if you don't have stomach acid, you can't absorb selenium, iron,
Right.
calcium,
Mm-hmm.
magnesium,
Mm-hmm. Mm-hmm.
iodine, iron.
Wow.
And now you're inhibiting nitric oxide production, causing an increase in blood pressure. If you've got plaque, it's causing that plaque to become vulnerable, rupturing, heart attack, and stroke.
Mm-hmm. Mm-hmm.
And if you don't have stomach acid, you can't absorb selenium, which is involved in insulin signaling and glucose uptake. If you can't make nitric oxide, you can't bring glucose into the cell, you develop insulin resistance.
Mm-hmm. Mm-hmm.
And if you look at Alzheimer's, it's focal ischemia, it's insulin
Mm-hmm.
resistance, and then you get protein misfolding.
Mm-hmm.
So if you can restore nitric oxide, you can restore blood flow, you can restore glucose uptake, and you don't get protein misfolding.
Wow. Okay. Are we seeing the deficiency of nitric oxide in young people, same as in older people? I know that it gets worse with age, but studies done in people in their 20s and 30s. Is there any science on that?
Yeah, so you're seeing 20, 22-year-old kids with erectile dysfunction.
Mm-hmm.
They're obese,
Yeah.
they have metabolic disease, hypertension, erectile dysfunction, and all of those are symptoms of nitric oxide deficiency.
Mm-hmm.
And there's also some FDA cleared medical devices where you can look at what's called flow mediated dilatation.
Mm-hmm.
And so it tells us how active or functional the endothelium is.
Mm-hmm.
And through population based studies, we're seeing 20 to 22-year-old kids that have a vascular age of a 60 or 70-year-old.
Wow. Mm-hmm.
And, so we can accelerate that process and we can also decelerate it.
Mm-hmm.
Because I'm 50, I'll be 51 in November,
Mm-hmm.
but I've got the endothelial function, of a 32 to 36-year-old. So we know that we can shift this to the left or right,
Mm-hmm.
again, depending upon our diet, our lifestyle, and what we put on our body and what we put in our body.
Mm-hmm. When you're talking about the endothelial function, let's go into that a little bit more. My understanding is that there's a like a gel-like layer called the glycocalyx, and I think it's within this that the nitric oxide is released. Is that correct?
Now, the nitric oxide synthase is found inside the endothelial cell.
Okay.
So the glycocalyx is like this carbohydrate type um, layer, and it protects the endothelium from the shear stress in the lumen of the blood vessel.
Right.
So it really creates this cell-free zone between the endothelium and monocytes, neutrophils,
Mm-hmm.
red blood cells,
Mm-hmm.
and platelets.
Mm-hmm.
When you destroy the glycocalyx, now you have shear stress. You can damage the lining of the endothelium.
Mm-hmm.
You get an upregulation of adhesion molecules, and then monocytes, neutrophils, platelets start sticking, and we call that vascular inflammation.
Mm-hmm.
So they're two really independent organ systems.
Mm-hmm.
The endothelium is completely separate from the
Mm-hmm.
glycocalyx, but the glycocalyx helps protect the endothelium. So we have to address both of those.
Right.
But just by restoring the function of the glycocalyx doesn't ensure that you're going to get an improvement in endothelial function and enhance nitric oxide production.
Mm-hmm. Okay, so let's start talking a little bit about supplements. So people can take nitric oxide. There's many different companies that are doing that. What should somebody be considering when they're taking a supplement? Because and are these forms of supplement basically taking nitrates in, or how is this working?
There's so many companies out there selling nitric oxide products. And what I try to teach and educate physicians, patients, and consumers
Mm-hmm.
is that nitric oxide is a gas.
Yeah.
It can't be delivered in a capsule, can't be delivered in a gummy or a chew. Your body has to. The strategy of most companies is they're going to give you precursors and substrates, and when you consume them, they're going to hope that your body can make nitric oxide out of it. But the people that are nitric oxide deficient have lost the ability to utilize those precursors to make nitric oxide. So giving more is not going to produce nitric oxide.
Mm-hmm.
So what we discovered and how we move forward is completely different than anybody else. And in 2007, we discovered that nitric oxide is a hormone. And what that means is that prior to our 2007 paper in the Proceedings of the National Academy of Science,
Hmm.
the scientific community thought that nitric oxide can only work in the cell in which it was produced or a neighboring cell,
Hmm.
because once it's produced, it's gone in less than a second. But in our 2007 paper, we discovered that nitric oxide has an endocrine function, meaning that if it's produced in the heart, it can have effects in the liver, in the brain,
Hmm.
in the lungs. So it has systemic effects. So when you start to develop rationalized therapy, you have to go back to how do we do hormone replacement therapy in patients? And in men, if you're testosterone deficient, we don't give you DHEA
Yeah.
or
No.
precursors, hopes your body makes testosterone out of it. In type 1 diabetics, we don't give you 21 amino acids and hope your body makes insulin out of it.
Right.
That's the problem.
Yeah.
So you have to restore this active molecule.
Yeah.
So in hormone replacement therapy in men, you can give testosterone
Yeah.
intramuscularly, you can give it
Yeah.
transdermally, you can give it orally through a troche.
Hmm.
You don't have to give it in the test, thank God. Right? So it's the same with nitric oxide.
Yeah.
We have to give this actual molecule,
Hmm.
the bioactive nitric oxide gas. And so that's what my product technology does, which no other company does and no other technology provides. And so to do this, we had to create an orally disintegrating tablet. You put it in your mouth. As it slowly dissolves, this matrix falls apart and it generates about 20 to 30 parts per million nitric oxide gas.
Oh, so it doesn't it's not requiring the bacteria in your mouth to take action or
No, because if we did that, then 1 out of 3 Americans would get an effect from our product.
hmm.
I don't want to rely. If your body can't make nitric oxide, then I want to do it for you. If your testes aren't making testosterone, we got to give it for you.
Hmm.
If your ovaries aren't making estrogen, we got to give you estrogen.
Hmm.
We can't rely on your body to do it because that's the basis of your efficiency.
Hmm.
So we overcome the bacteria.
Yep.
But the most important thing, I think, is that not only are we producing nitric oxide gas, but because it's an orally disintegrating tablet, we're helping to restore the oral microbiome, restoring the diversity, increasing the number of nitrate-producing bacteria, and we figured out how to recouple the enzyme in the lining of the blood vessels.
Hmm.
We're preventing the oxidation of tetrahydrobiopterin.
Hmm.
So the lozenge does 3 things. Number one, it provides nitric oxide
Yep.
as a hormone replacement. It restores the oral microbiome, facilitating this enterosalivary circuit, and we're improving the function of the nitric oxide synthase enzyme in the lining of the blood vessels. So we're actually improving the body's ability to make nitric oxide on its own.
So, sorry, how does that happen that it improves the microbiome? Why would that happen?
Well, because most pathogenic bacteria
Hmm.
are sensitive to nitric oxide.
Right.
So nitric oxide binds to the iron sulfur centers of these bacteria and shuts down their respiration.
Hmm.
Most non-pathogenic commensal bacteria are actually nitric oxide producing. So if you selectively generate nitric oxide in the oral
Hmm.
cavity, you're selectively killing the pathogens and you're giving the nitrate reducers a substrate to respire on. These are facultative anaerobes, and you're waking them up and improving their numbers. And we're also enriching the saliva in nitrite and then providing the electrons along with that. So even if you can't make stomach acid,
Hmm.
we're providing that reductive capacity when you swallow your saliva and you're generating nitric oxide in the lumen of the stomach,
Hmm.
even if you're on an acid.
Hmm. Okay, that makes sense. How often do they have to take the lozenge, and how long does it last?
It's a very good question. But in order to answer that question, we first had to understand how much nitric oxide is a normal healthy person making in 24 hours.
Yeah.
And through radio-labeled isotope studies and just through normal dietary uh, patterns,
Mm.
we could determine how much nitric oxide is being generated in a 24-hour period.
Hmm.
And what I'd hope to do as a physiologist is recapitulate endogenous production. I don't want to give the body more than what it's used to seeing, and I want to make sure that I'm getting enough to be biologically active.
Hmm.
So originally, I designed that to be a once daily nitric oxide kind of a technology.
Right.
But again, if you look at the pharmacokinetics, we see peak plasma concentrations within 20
Yeah.
minutes, and then you get a half life of what we're looking at is plasma levels of nitrite of about 2 to 3 hours.
Hmm.
So what that means is every 2 to 3 hours, 50% is gone. So then another 2 to 3 hours, you have 25% of what you put. So then we thought, okay, well, let's develop a once daily, kind of a BID, once in the morning, once in the, and then that would kind of stabilize the pharmacokinetics and give you kind of 24-hour coverage. So that's kind of what we recommend for people who, like me, who don't have any symptoms but want to maintain a steady level of nitric oxide production. But for people who are chronically deficient with ED, high blood pressure, metabolic disease, their requirements are much different than me, who is metabolically healthy.
Hmm.
And so for those, we just have to titrate in based on their symptomology.
Got it.
And really, we rely on the medical practitioner, the physician, to titrate best on their best medical judgment.
Right. Okay. So do you think it's a morning thing or a evening thing? Is there any difference you would think
Well,
before
I think
workout
if you look at
matter?
the data, most heart attacks and stroke happen first thing in the morning.
Right.
So if you've got a patient that's at risk and you have high blood pressure, you have plaque deposition, you have stenosis of your coronaries or your carotid arteries, then I would certainly recommend, the first thing you do when you wake up is take a lozenge.
Hmm.
And especially if your blood pressure doesn't dip at night, it's what we call non-dippers, when your blood pressure doesn't lower at
Hmm.
night while you're sleeping,
Hmm.
then I think the data tell us that that increases your risk of heart attack and stroke by 5 to 10-fold.
Hmm.
So those are the patients that are really at highest risk.
Okay. And what do you think about does it have a synergistic effect with people taking like these Viagra, Cialis, Levitra, these type of medications?
Yeah, no, for sure. I mean, we see it clinically and mechanistically, it makes perfect sense. Because as I mentioned before, the PD5 inhibitors are inhibiting an enzyme called
Yeah.
phosphodiesterase. Phosphodiesterase enzymes break down cyclic GMP. So nitric oxide leads to an increase in cyclic GMP, and the PD5 inhibitors prevent the breakdown of cyclic GMP. And that's why you're warned against a 4-hour erection, an unsafe drop in blood pressure with these drugs, and all the side effects. Because I like to say nitric oxide turns the switch on, and Viagra keeps it on.
Right. Keeps it going.
But
Right.
if there's no nitric oxide to turn the switch on,
Hmm.
the drugs like Viagra don't work. In fact, they can't work. So if we prime the pump, metaphorically and literally,
Hmm.
then we can potentiate that signaling and now enhance the therapeutic effects of the PD5 inhibitors. And more importantly, you can titrate down the dose of these drugs, mitigating the side effects
Hmm.
and enhancing their therapeutic effects.
So do you think that explains why some people notice that these drugs do not work after some time, or they develop like a tolerance? Do you think it's because they're using up all of their reserves of nitric oxide?
Yes, there may be some off-target effects, and you get an upregulation of phosphodiesterase enzyme itself.
Hmm.
But I think what turns this second messenger system on is nitric oxide. Without nitric oxide, there is no cyclic GMP. Without cyclic GMP, the PD5 inhibitors have nothing to work on. So there's no increase in blood flow.
Okay, that makes sense. So what's the name of the brand? And if you don't mind letting our new viewers know where they can get it from, and I will put it in the show notes as
Sure.
well.
So the products we develop have the N101 brand. So it's the letter N, the number one,
Hmm.
the letter O, number one.com,
Hmm.
N101.com. So we make the lozenge. Beets have been a hero vegetable for the past 15 years,
Hmm.
but 95% of the beetroot products on the market don't work. There's no detectable nitrite. All they do is turn your pee and poop red and cause a lot of anxiety. So we thought if people are looking for beetroot products, we know how to do this. So we ferment our beets, we pre-convert it, and we make a product called Inno Beets, which is, in my obviously biased opinion, but I think the data will corroborate that. It's the best pre-workout product on the market.
Hmm.
It's the best energy product on the market, a safe, natural energy source.
Hmm.
And then we also make a skincare line,
Yeah.
topical nitric oxide for fine lines and wrinkles and some dermatological issues. But I think more importantly, we're developing this technology into drug therapy. So I've taken the lozenge
Yeah.
technology, and we've got a drug company called Bryan Therapeutics, and we have that drug now in clinical trials for ischemic heart disease. We've got a drug for Alzheimer's, and we're taking our topical drug technology and developing a drug for diabetic ulcers and non-healing wounds.
Wow.
And remarkably, we haven't seen a wound that we haven't been able to heal. 3, 4-year-old non-healing ulcers in paraplegic diabetic patients, we heal within 6 months. It's really remarkable. I think it's going to be a game changer.
And same one lozenge, or that those types of things require more dosage, you think?
Well, the drug is going to be a higher dose and potency
Mhm.
than our dietary supplement. So I equate it to, there's precedence for this. There's a prescription drug called Lovaza
Yeah.
for hyperlipidemia.
Yeah.
So it's basically a fixed dose combination of DHA, EPA.
Yeah.
You can go to the and get it as a dietary supplement,
Yeah.
or you can go to your physician and get that particular drug prescribed for you. And there's the same thing with some prenatal vitamins that are prescriptions. So we're going to follow the same model. Dietary supplements are designed to supplement missing nutrients that you're not getting from your diet. And it only has to be safe. We can't make efficacy claims or drug. To get a drug approved, we have to demonstrate safety. We have to demonstrate the right dose for the right indication. And then we have to demonstrate efficacy for that indication.
Right.
But I think most important for me is I want to be able to give physicians a drug that they can prescribe to their patients that's safe and is very effective.
Hmm. Okay. Yeah, that totally makes a lot of sense. So is that what your focus is on right now, to try to see if you can create a drug, version of nitric oxide in effect?
It is. Yeah, we've been very successful in the dietary supplement nutritional
Hmm.
space. Our skincare company's doing very, very well. But for me, I got into academia 25 years ago
Hmm.
for drug discovery. I mean, I wanted to understand human disease to the extent that we could fix it
Hmm.
and develop rational therapy. So I think that's the next frontier of nitric oxide,
Okay.
is taking this technology that's known to be safe. We had a drug in phase 3 clinical trials during COVID, and we treated over 600 high risk, highly susceptible, really sick patients, and we didn't see any safety signal. So we know this drug is safe,
Hmm.
which is very important because the third leading cause of death in America is prescription drugs.
Hmm.
So, drugs, even though they're approved by the FDA based on safety and efficacy,
Yeah.
these drugs are given in isolation, not with other drugs, interactions, not at the doses sometimes people take. So what we do with our drug, we had patients that were on 15, 20 different medications, and just giving nitric oxide that repletes endogenous production,
Hmm.
there's no safety signal.
Right.
So I'm very confident that what we're doing is safe. Now the next challenge is to demonstrate efficacy
Hmm.
for ischemic heart disease, which I'm confident we're going to be able to do,
Hmm.
for Alzheimer's,
Hmm.
because if you think about Alzheimer's and what causes
Yeah.
Alzheimer's, nitric oxide fixes all that. Targeting drugs toward the amyloid plaque and the tau tangles, despite billions of dollars of money spent on research and all these monoclonal antibodies, they don't work.
Hmm.
And the reason is they're targeting the consequence of the disease.
Right.
They're not addressing the
The
cause.
root cause. Yeah.
What we do is addressing the cause,
Yeah.
which is decreased blood flow, the focal ischemia. It's the insulin resistance, the diabetes type 3. It's the increased inflammation and protein misfolding. Nitric oxide dilates the blood vessels, improves cerebral blood flow. It enhances glucose uptake, improves insulin sensitivity.
Hmm.
And if you get oxygen and nutrients to the neurons, you take out the waste product, there's no protein misfolding.
Hmm.
I mean, that's just basic physiology.
Hmm. Hmm. Yeah, that makes a lot of sense to me. Okay, this has been very useful, and I think our listeners will really appreciate this. So I'm going to put it's n101.com. Is that correct?
Yeah, not N101, but N101.
Yeah, okay, yes. And
And then for those interested in keeping up with our drug development, it's BryanTherapeutics.com.
okay, awesome. I'll put that in the show notes as well. Thank you so much. Thank you. I really appreciate your time today. It was excellent.
No, thank you. I appreciate the
All
opportunity.
right. Hi, I hope you enjoyed today's talk with Dr. Nathan Bryan. Today we learned so much about nitric oxide and all its health benefits. So take a look at the show notes. There's a link there where you can get 10% off your order of his proprietary supplement to increase your nitric oxide levels. You can also learn more at drnathanbryan.com. Again, we're at peakhuman.ca. You can also find us at shoppeakhuman.com. I hope you enjoyed today's episode. Please like, subscribe, and share this with other people who care about their health and want to be in the top physical condition. All right, take care. Bye bye.